Alright, in this video we're going to be discussing the properties of acids and bases. If you see the cat meme on the left that says, you want to destroy their base? Well, we'll just use some strong acid. Destroy their fortress. Fortress of Solitude, maybe with Superman. I'm not sure. There are two main definitions of acids and bases. The first one we're going to talk about is called an Arrhenius acid and base. In an Arrhenius acid, they produce hydrogen ions, H+, in an aqueous, that means aqua with water, solutions. For instance, if I have HCl, or hydrochloric acid, it will dissociate or break down into hydrogen and chlorine ions. This would also conduct electricity because we have positive and negative ends, right? A base will produce hydroxide or OH negative ions in an aqueous solution. So I have NaOH. If you dissociate it, it breaks up into sodium and hydroxide OH ions. Notice when you're looking at these, the acid produces your H+, your bases produce an OH minus. What do you get if you combine H and OH? You actually get water. Water will actually be the product that forms. So from that joke on the last slide, how do you destroy the base? Put an acid there because then you make water out of it. The second definition of acids and bases is from Bronsted Lowry. Those are the names of the scientists that created it. In a Bronsted Lowry acid, they're hydrogen donors. Donors means they give up hydrogen. The same example of HCl, it still works because it's giving up or donating the hydrogen ions, right? Bases are considered a hydrogen acceptor. It's taking in the hydrogen ion. So if I'm looking at HCl and I mix it with water, the HCl, obviously the hydrogen is going to be donated to make an acid, but in this case, what takes in the hydrogen? It'll actually be the H2O. In this case, the water would actually be considered a base based on the definition. Here's some of the characteristics of acids. Again, remember they produce hydrogen ions and water. They taste sour in general. Citrus acid, if you drink grapefruit juice or orange juice, that's sour tasting. They corrode or eat through metals. My first year teaching, unfortunate story, someone took a thermometer and it actually had metal in the outside of the thermometer, which luckily we don't have most of those anymore. And without noticing, he actually put it in an acid. It started actually dissolving the metal, and that produced hydrogen gas. Hydrogen gas is very dangerous because if you breathe that in, you could actually hurt your lungs and not get oxygen into our bodies. So we had to evacuate the room, we had to air it out. Luckily, we put it under the fume hood, so no one actually got hurt from it. But pretty scary feeling seeing a random white gas just getting produced in the lab. They also react with bases. They'll form water, as you saw, H plus OH makes H2O. They also form salts. If you want to eat, say you ate sea salt or kosher salt, they actually make the salt from an acid and a base. That makes a very pure form of the salt. Name of some common acids, HCl would be called hydro because of the hydrogen. Instead of chloride, it'll be chloric acid. The second one, HNO3, is not nitrate, it's nitric acid. If you look at NO3, NO3 is nitrate. The way to remember these is if it ends in ate, if you ate something, it feels icky. Okay? Ate goes into ick. Next one is H3PO4, phosphoric acid because it's phosphorus. Sulfuric acid, that's what causes rotten eggs and smelling like your tires when you burn rubber when you're driving. And acetic acid. Acetic acid is vinegar. Bases, remember, produce hydroxide ions in water. Instead of the sour taste, it actually tastes bitter or chalky. Okay? Soap is an example of a base that's used for cleaning things. If you actually accidentally taste soap, it's bitter. They're electrolytes. That means they can conduct electricity, just like acids. They feel soapy or slippery, especially. And they react with acids again to form salt and water. So they kind of complement each other. Again, pure water is neutral. You have small but equal amounts of H3O or H plus ions and OH minus ions. If I put two molecules of water together, you could get the same amount of H3O and OH. This would also be called hydronium for H3O, hydroxide for the OH. The key number to remember, it's 1 times 10 to the negative 7th power. When you look at the 7 here, that has to do with the pH. That tells you how strong of an acid or base it is. So if you look at your formula chart, you'll see the equation for the Kw, that's for the amount of ions in water. Let's say you have the OH of a solution is 1 times 10 to the negative 3. What is the H3O plus? When you look at your formula chart, they give you this equation. The H3O times the OH has to equal 1 times 10 to the negative 14th power. So all you do here is you divide 1 times 10 to the negative 14 by the 1 times 10 to the negative 3, and you get 1 times 10 to the negative 11. That would be how strong the acid is. You notice it has capital M. That has to do with your molarity or how strong the solution is. The other equation you have on solutions involving pH. pH shows how acid the solution is. All you have to do is on your calculator, once you find the molarity of the H or H3O plus, you just do the negative, press the log button of that number, and that tells you how strong your solution is. It actually comes from the French pouvoir, hydrogène. Pouvoir is the P, hydrogène is the H. It actually means hydrogen power. The more hydrogen it releases, the stronger it is. That's why our pH will be stronger. Some numbers for H3O plus and pH. If you do negative log of 1 times 10 to the negative 5, you just get the number 5. 1 times 10 to the negative 9, pH will be 9. 1 times 10 to the negative 11, pH is 11. Obviously, the lower the number is, the more pH you have, because you would have a smaller negative number. Remember, a negative exponent makes this really, really small. All right, class, so that's a quick overview of acids and bases. If you have any questions, leave a comment down below. All right. What unit was that? 11, I think? Okay. They're about to call you guys. Any quick science questions before you go?